All right, everyone. Thank you for joining us here today. My name is James Carr, joined today by a new member of our sales team, Kyle Vino. He joined our team last summer and has quickly dove into the kind of EPC world of working with folks that are working on standards, contracts, RFPs, which is industries that we've served in the past. And his focus on it has really opened up new opportunities for us in that whole world of procurement and the way people write specifications and that kind of thing. So for our webinar today, I'm going to thank everybody for taking the time and those joining us on the recording. We're going to be talking about the connections, correlations, differences between systems engineering thinking, systems thinking compared with procurement engineering. So I'll turn things over to Kyle to give us an overview of the discussion, and he and I will be going back and forth as we walk through the subject matter here today. As we go, if there are any questions, feel free to enter them in the chat. We'll have a time at the end where we address the questions. We might grab a couple throughout the way as we go, but certainly any questions that you have, throw them into the chat there. And if we don't cover them in the remainder of the presentation, we'll be sure to circle back to those and give you an opportunity as we're getting close to the end to be able to do that as well. We've got an hour scheduled, and Kyle's going to give us a walkthrough of where we're heading today.
Awesome. Thank you, James. Yes, like James said, I'm Kyle Vino, and I'm one of our executive sales reps here. Essentially, what we thought coming up this webinar was we saw direct correlations, and we wanted to illustrate how they are very similar. So when you look at procurement engineering versus systems engineering, although two different fields and many times separated, there is a massive correlation between the two. Then we took a look and we want to dissect how every project is a system. So are they? Can they be? Yes. And we're hopefully going to show you that throughout the presentation. Systems thinking in project management and procurement. After we've gone through the top two, hopefully we've drawn the direct parallels, and it will just have that aha moment for everyone where you can really see how we can save time and a lot of rework throughout by applying one to the other. And then lastly, we're going to talk about developing requirements like systems engineering, when, where, also the why, on why you're going to see how this will help everybody and the overall and benefit the overall project very well.
Awesome. And along that as well, any of you that are customers of ours or are friends of the company, you know that our main focus is on requirements. So that's the area of systems engineering where we have the most interest, I'll say. We're also going to be sharing with you as we move through the presentation other folks that you can follow either in the procurement world and the spec writing world and also in systems engineering. If you're active on LinkedIn, folks that you can follow that will just be good to kind of dig into those spaces a little bit more and hopefully provide some interesting insights that you can apply beyond the requirements, which is going to be the main focus of what we talk about here today. The first one is someone that Kyle connected with through LinkedIn is Jeffrey Potter. He's actually giving a webinar of his own, I think, later on today. And he had a couple of interesting quotes from his blog there that Kyle wanted to share.
Yeah, so like James had said, we connected through LinkedIn, and we wanted to really, when you're dissecting this process, we really thought, okay, what symbolizes everything that we're talking about? And really, it starts right here. Is just because you have been doing the same thing a certain way for years, decades, forever, doesn't mean that we can't change it. The art of specification writing, which it is an art, hasn't changed much. And what we're really doing is we're seeing this in the digital age. The trend now is to going towards digital engineering. And, there's a place for everything in that as well. The other thing was, and this is, again, simple is best. This is what we've always talked about in our requirements writing, in systems engineering, is, what if the product information that should be specified is the information that the product manufacturer needs to provide a good estimate, therefore increasing their chances of winning the bid and protecting the established minimum quality and the owner. In essence, again, say what you need and you'll get better results. Using elaborate methodologies, there's not a need. Simple is best.
Yeah, so we'll kind of compare and contrast procurement engineering versus systems engineering. So when we talk about a procurement engineer, you can think of the procurement engineer as the person who oversees the purchasing of technical goods for an industrial operation. The procurement engineer also ensures that the purchased goods are delivered as promised. So there's that circle, and we'll talk about that when we get into systems engineering, that everything is designed in those systems and the different methodologies that you follow in order to trace back to, did this meet the actual original need? So do the actual goods that were delivered meet the intended purpose, is well aligned with the purposes of systems engineering. So systems engineering allows you to build, analyze, manage a system involving one or more business processes and logistics. So I like the way that it was said in this description, it transcends the physical nature of what is designed and managed. And lastly, if it consists of multiple interacting components performing a function, that cannot be achieved by any one component alone. So it transcends this idea of, this is the actual product in place and these are the physical components. It's actually the interaction of all of these systems together is what makes something a system. So if we put those two things together and think about the question, in what way or how is every project a system, we can actually take those two things and put them together.
True. Every project has a deliverable. At the end of it all, you need to know the outcome. If a project is consistent with multiple interacting components performing a function that cannot be achieved by any one component, then the project is a system. In essence, if you look at it, I'm going to break it down even to a simpler aspect of it all, is the components of the project are the organizations, the employees, the equipment, software, and the materials. And another way to look at it, and we'll reference this throughout a presentation, is if we looked at it as a puzzle, the original goal is the picture on the box. You're given a number of pieces. One individual piece will not show that full picture. You need to put them together. And whether you have a plan of how you put the puzzle together, or you're just going to see what fits, at the end of the day, you really do have a plan. And that's what we really want to illustrate throughout this presentation, is how a plan will work. Everything is a system. Here we go here. This is a group of fine people in our organization, and they're actually going out for drinks after work. This is a system. The process and the goal are, how are we going to get together after work for drinks? Well, let's send a simple text to everyone. We always meet at the same spot. So we have a place, we have a when, which is after work, and our means of contacting everyone is a text. That is a simple system. Now, let's exemplify this. This fine gentleman, one of our friends, which James will draw, a colleague, BK, he's getting married actually next month. And he has about 2,000 people attending his wedding. Now, what we thought is if you could just send a simple text to all those 2,000 people, like after drinks 2 hours before the wedding, it may not work as well as a simple text for people to have some drinks. There's a number of complexities, and that's what we're talking about when you look at grander scale projects, is the complexities increase, the stakes get higher. As you can see, a failure for someone showing up for drinks is not a big deal, but a failure for some people not landing at the wedding, or the right flowers, the right dietary restrictions, the right venue, there's a number of complex projects, the music, the dress. There are people all over the world coming to this, and 2 hours is just not enough time. So pairing the system and the process will make this so much easier. So small systems engineering will not work, but big systems will always work on small projects. So if we look at this and you look at your own project, so we look at small projects, we know where we start and we know where we have to finish. To get there is the key. By having clear requirements, it's a straight line. Now, if we look at another project that has many components, extremely complex, and our requirements or standards are written poorly, all of a sudden we're going along smooth and there's a hiccup. We have to rework it. We have to resupply. We have to get it verified again and start writing again. And then there's another hiccup. And again, we're going back. And, it's time consuming. Now we got to have it reworked. We have to consult other people. So the goal when we look at every system is every project is a system, is we can create a straight line on complex projects by using systems engineering. This is the goal, and the time sensitivity will start to lessen. And all of a sudden our projects will not have to be delayed and delayed and delayed. There'll be a direct line, and all our stakeholders will be extremely happy with how our project outcome is accomplished.
Yeah, and what we found is, the big companies that we work with, that are doing this type of work. You think of the oil and gas industry and large infrastructure projects that have applied this thinking, is, regardless of whether you're applying, methodologies to be able to straighten that line as much as you can by doing the upfront work of requirements well, no matter what, you're going to end up delivering what it is that the customer expected, or you're going to get what you're asking for if you're the customer in these cases where you're bringing on contractors. You're going to get there eventually. It's just a matter of how much rework is going to be involved in that process, how many misunderstandings are there going to be along the way, how much clarification is going to be needed, how much extra communication will you need to provide because you don't have the plan kind of laid out front. And so some examples of this in the real world, I'll give you another person to follow here. I got to clear our artwork out here. There we go. Is this one. So Bernardo here shared, you can find him on LinkedIn. He's a systems engineering professional, systems thinker, and he shared this news of what happened in Spain recently, where 250 million was spent on trains that were too big for the tunnels that they had there. So his analysis of this was, it's amazing and unbelievable that now in the 21st century, these same mistakes, poor understanding of the requirements, are repeated over and over again. When engineering discipline, so-called systems engineering, can help on that. So surprisingly, most of the engineers worldwide are not educated in this discipline at the university, despite being known of since the 40s of the last century. And he references INCOSE, that's the International Council on Systems Engineering, as being the international reference in this discipline. So again, our focus is primarily on the requirements, and a lot of the time the requirements fall into a systems engineering context because that's the world where we live, and requirements are essential to the systems engineering approach. And so we're going to show you an example of looking at one of those methodologies that's used often in systems engineering, and kind of where that applies as well. And the idea is, if you look at the time and cost of correcting errors, this is one from IBM Sciences Institute. These results have been duplicated over the years, and you really don't need the research to know this. If you can fix something when it's just text on the page, the time and cost of correcting it there versus when design had been done on this versus verification stage versus when it's in market, the time and cost of fixing that issue goes up pretty much exponentially, especially once it's in market. So in the case of the Spain trains, they were actually found in the design stage. So it's going to be a lot more work than if they had discovered it early on, because they had already procured these particular train cars, but they were able to make modifications to be able to make it work, just at a great expense. And so the methodologies that are used, that is being referred to here, that could help prevent things like this from happening, is following a development model, global design and development model, which we'll talk about in a moment, that actually just help ensure this one thing. If all of the requirements are met, so the things that you've documented as being the requirements for this project, does that mean that the needs of the project have been met? And that is really the big question that needs to be answered. Does the process that you have in place, whatever it looks like, whether you call it more of an agile methodology or using a waterfall approach or have different methodology from project management world, you need to have a mechanism in place to ensure that the requirements that you're trying to fulfill actually do meet those needs. So this is blurred out intentionally, don't adjust your monitors, but this is the V model that's often used in safety critical industries and in the systems engineering world. And the phases that you go through here aren't as important. We will show them in a moment here, but I just wanted to highlight what we mean when we talk about the V model. And this is basically the process of decomposing and designing your system and how it's all going to work together. So you start with the high level needs of what the project needs to accomplish, the systems engineering plan of how it's all going to come together. You document your system level requirements, those go into subsystem level requirements, and down you go. And then once you actually have a specification, so this is exactly what we're going to build. We have the materials, the exact design, the drawings, everything is all there. Then you actually build the thing. So in the V model, we're going to be looking at here, and we will reveal it in a moment. When you get to the other side of that V, and the reason they call it a V is this is your traditional kind of waterfall development approach of a project going through phases. And really the V model is just going back up the other side for what they call verification and validation. So verification is ensuring that you built the thing correctly according to the specifications, according to the requirements. And then validation is ensuring that you actually built the right thing. So testing each of those different stages versus those original needs that you've identified. So I mentioned we see this more often in particular industries. So these are the industries where a model like this is mandated. You have these safety critical industries or projects where it's heavily regulated because of the safety critical nature of it. And then you see pieces of this also in the industries that that employ different forms of engineering, but don't have the same degree of systems engineering being applied to it. And we're seeing a trend, of course, in oil and energy. More of these applications are being described. Of course, infrastructure ties back to high-speed rail. There's some overlap there. Software, you also have embedded software that's a part of these. So these are general guidelines, but you're actually seeing it more and more that there's a trend towards this kind of systems engineering mindset. Along with different development approaches to be able to do that. But as we mentioned before, the end goal of all of this is to ensure that the finished product that you come up with is actually going to meet the intended need. So here it is in this particular model, and it's different terminology is used in different models as you see them. But basically, as you can see, as you go up the other side, as we talked about, you have your process of verifying. Okay, we've built this component. We want to verify that it actually meets the specs. We have this system now of all these components coming together. We're going to verify that the subsystem meets those requirements that we set out as we were developing it. System verification. We want to ensure that this whole system now, everything all works according to the requirements that we've laid out. And then that important part is the validation. So this top line of validating that this solution that we have in place actually meets the original intended needs. So not just the requirements, the system level requirements that we've documented, but the actual overall scope of the original kind of stakeholders and people that had an opinion on this, whether it actually meets those original goals. And so we see this as a linear model of saying these are the phases and stages that go through. Really, these are developed in concert. It's more like layers of information that you're looking at as you go through the project. So you might have at any stage that you're going through particular, what subsystems are going to be involved with this. And so you've kind of designed that around it. But this is, you can see high level design starts here in the red at this point. And really you're constraining the design as you make design decisions, and that introduces new requirements and allows you to get more specific. So in the procurement world, you're not necessarily going through all of these projects or all of these stages or processes. It looks a little bit different because you're bringing in subcontractors, you're bringing in partners to work with on this project at different stages of this development. So you're not necessarily designing everything all the way through before you introduce somebody to hand off. So that's where it looks a little bit different from what we see here. You might be just at this like kind of concept of operations stage where what the project is supposed to cover, and then you're introducing subcontractors and contractors to be able to work on this project, to be able to define these different stages. And from that perspective, the important thing isn't that you carry something through all these stages before you hand them off to the next team or the next company that's going to be involved in the process or your supply chain, but actually just keeping this in mind as you write your requirements is the important part. So developing this, knowing that somebody's going to have to take whatever you've documented as what I want this project to accomplish or what I want this system to achieve, and somebody's going to have to break that down into these individual pieces that ultimately add up to that design. So what we see here as being a linear approach where you go through all these stages, and then at the other side you go, okay, now let's verify all of these things. This really happens during the process, and INCOSE has some additional guidance on this that shows how it works. But basically, after you've written these system level requirements or moved on to the next phase, you want to go back at that time and verify, does this actually meet the needs? When you write the requirements at this level, you want to make sure that all of these requirements trace back to meet the needs at the level above. And you also want to check that if all you do is meet all of these requirements, does it actually fulfill the original intended need? And that's making sure that you don't lose anything along the way as you go through that process. So by the time you get to this other side of actually the finished system that it's built, this hopefully is just, a formality of going through and doing the final verification that these things are all true. But you're actually taking those steps as you work through the different stages. And each stage, you're getting into more detail of exactly how it works, but it's all tracing back to those original needs that you've laid out.
And many times, James, sometimes you're doing it subconsciously. If it's it's a process that you've done so many times and you're used to these, larger complex projects and working with them, sometimes if you do write it down, you may recognize something that may cause rework at some stage. So in essence, by documenting it from the start to the finish, you can uncover issues that may occur before they occur versus having to rework. Because many of the scale that is worked on, because it's such a large scale, the project will be done no matter what. And our idea is if we can find where the snags and the rework and the slowdowns are through the documentation, that'll actually prevent and speed up the process, but also make it much clearer to the end user and the stakeholders involved.
Yeah, absolutely. I mean, if you start the process down here, at the spec writing, this is basically what you would consider your specification. You've actually designed exactly the way everything's supposed to work. If you decide that you're just going to write a spec and then put it out as an RFP for people to fulfill, you've probably done some form of these stages of evaluating the stakeholder needs and bringing them in. So that's a good point too, of like what we end up with here before we start developing the system requirements, a term that's used, and there is some controversy going on around this right now, but you could basically think of this as when you enter into this phase of the project, you have what's called an integrated set of needs. So you've actually narrowed down, what the most important elements are. You've specified exactly not how everything's going to work, but what the project needs to accomplish, and those are going to be feasible. It's they're consistent with each other. You actually have a set of integrated needs, which we could consider like high level requirements that actually define what this project is supposed to fulfill. So some examples along those lines as well. I kind of show as it goes up the other side there. Does it meet the specs? Does it meet the system requirements? Does it move up? And then does it meet the needs? It's just kind of laying out those different stages that you work through. Should have been doing that as we go. But I'll point you to another interesting person to follow, Michael Burnett, listed at the bottom there of his blog. And he talks about these sort of competing methodologies, you could think of it, of the agile approach, which is primarily for software development. And then on the other side, we have the traditional kind of waterfall stage of projects going through these different phases. And there's an interesting observation there that agile falsely assumes that the feature will get revised. You kind of develop it quickly and iteratively, assuming that if there's issues with it, your customers will let you know, or you'll be able to go back and revisit it later on. And that doesn't always happen. Whereas waterfall falsely assumes that the product won't be revised. So you can't really look at either of these systems as saying like, we're going to follow this exactly and it's going to work for us. We'll plan it to death at the beginning so that we know exactly how everything's supposed to go. It's really fleshing it out at these different layers so that you see, okay, these are the overall goals that we're looking to accomplish. And then what are the steps that we need to take to break that down into who's responsible for each part of it? And then how are they going to break that down into ensure each step is being done? And it adds in there at the bottom, the practice of iterating on a living product in the market is a luxury of software. Updates can be pushed at any time. Assembly lines and tooling don't need to be revamped. Every technology product should be built in stages, but it also must be built towards an end goal and a fully realized product. So that's one of the differences, that as you see more of, agile methodologies, and a lot of time, agile methodologies only by name of, just saying that you're going to follow that methodology, you're missing that part where there are, with embedded systems, you have hardware and software that need to work together. And so planning in advance so that all the other teams know how the other pieces are going to work together is really important. So how do you bring those together? You're looking at these different methodologies from software and project management and systems engineering. And I'll bring in an example of another interesting person to follow, friend of the company, Oliver Hoyne. And I like the way that he describes this at the end. He's talking about how he is a systems engineering professional. He's also a project management professional and a certified Scrum Master. And that position enables him to be able to select from a variety of tools to get the job done in his context. So if you are on a procurement side of things, if you are working on managing contracts and that kind of thing, taking a systems engineering flavor to what you do and learning about those principles and systems thinking and systems engineering practices can actually allow you to problem solve the particular project that you're working on and have a better idea of how to construct, how to follow your process or how to design your process that best fits the types of products or the types of projects that you're looking to develop and implement. So all of that to say, if all of the requirements are met, the documented requirements that you have in your process, does that mean that the needs will be met? And that's what all of this comes down to. And in a lot of ways, that all comes down to the requirements themselves.
So then we have problems, facing the procurement process. And the big one is, when should the specifications process start? Well, as we saw in the waterfall example, the V example, many times specifications are, one of the last items written before the RFPs are issued. These are causing the time delays. In fact, specification writing should begin very early in the project life cycle. Early stage specifications can be seen as part of a review with the purchaser, internal or external, to define the project outcome. So when you have a number of parties involved, and every piece is interacting with each other to see that big picture, or referring back to the puzzle yet again, is you need a number of pieces to see that big picture, because one will not. By examining these in the early stages and seeing how they will interact and complement each other, this will prevent a lot of rework, time delays, or costly mistakes, whether it be time or purchasing the wrong thing at the wrong time. So we want to induce, we want to have a lot of quality, and you'll see it in the next slide that we talk about. Is there's a number of things that you really got to take into consideration, in early stage development, and understanding of performance requirements of the project. They must be identified. It's the stakeholder review meetings and discussion on the development of the project, the complexities, the entities, the space, location, the elements, systems, and the products will define the scope of the project, creating a buildup of specifications. We do not want to have an increase in the amount of extra work. Keep the project scope on target. All project outcomes are made up of the same goal. The biggest thing that we always try to achieve is to create a common language throughout. And then when you look at it, all project outcomes are made up. How do you define success? Well, it's the quality, the quantity, the time, the cost. And then by having these goals laid out, as we refer to throughout, that puzzle, seeing, are all those pieces together? Do they look like the picture on the box? And if you can say yes, unequivocally, then you know what? You have accomplished what you're supposed to do, and everybody will be happy. So the key is to know the pieces, how they interact, to really, fulfill that need and make sure that everything is met and everyone's happy.
Yeah, I mean, to tie that back, where it said in the last one that a lot of the time, the specs are one of the last thing that's done. That means that you've done all that other work, whether you've documented or not, to trace it back to the original needs. There's always requirements, whether you document the requirements or not, or just try to write a specification or write an RFP that says hey, this is what the project needs to accomplish. You always have the requirements. You just don't have the same level of certainty that you're actually going to meet the intended goals of the project if the requirements are met. So being able to tie those two things together, of ensuring that the way that we write the requirements is such that when you write your specification, you come up with the actual design that's going to be followed, whether it's you or one of your contractors that are working on that with you, defining the success of the project out front, and then making sure that all of your requirements tie back to that, is an important part of the process. Whether you've documented it or not, they're still there. It's just by documenting it, it allows it to get things open in the open and realize, maybe some ways that you've defined things don't really have a clear metric that you can go back and test. Which brings us to the next one, which is more in our space, and we're going to get a little bit more practical here in terms of how this actually applies to any of the different types of projects that you might be working on personally, which is that requirement best practices are universal. So there's all sorts of different terminology that's used to define them. And we found from working in medical devices and aerospace and defense and oil and gas and procurement and IT development and semiconductors, in all those spaces, companies come up with their own kind of rules for people to follow or best practices to consider when defining their requirements at different stages. And there's trends that emerge from that. So one that's common in the procurement and engineering world is the 4 C's. And so we'll look through those through that lens. And these apply also to kind of best practices for requirements engineering. So these are universal. So when you're defining a requirement, first of all, it needs to be clear. There must only be one way to interpret the requirement. It must be possible to know by observation of the finished system or product that the requirement has been met. So that has to do with being testable as well. You'll see some of these bleed into each other because 4 is a very kind of a small number to define these, but the clarity of the requirement is important, that somebody's not going to interpret it in a different way.
And then concise. I mean, each requirement shall stand alone as a singular statement with a defined actor. So we know who is responsible, they know their outcome, we know exactly what our intentions are. And the idea behind that is when writing them, let's spend less time discussing and more time just exactly working on what needs to be done. So this way, preventing that misinterpretation, that who is the actor, who's doing what, is this me, is this you? Let's just keep it very precise, let's make sure everybody knows and there's no misinterpretation whatsoever. So we know exactly what's going on.
Yeah, and that's one big difference in sort of the systems engineering world that we see as a best practices that's more established. If you're following, if you're using a requirement management tool and you have your requirements documented in a singular way where each one has an ID, that is more common in the systems engineering world than it is in kind of procurement, generally speaking, than in like an EPC kind of setting where you're issuing contracts and issuing RFPs. A lot of the time in those contexts, if you're working with standards or project-specific requirements, it's less likely to see those atomic statements, but it doesn't make it any less important because those singular statements are the way that you can actually trace each requirement back to the original need. We actually have a blog post coming out on this soon where you can read about sort of the benefits of atomic requirements if you're not currently writing them in that kind of singular format. So check back to our website for that. And then the next C is the correctness of the requirement. So each requirement must meet an agreed upon need within the project. So the set of requirements needs to cover the entire scope of work, and it's required to know where that requirement originated. So if you can think of those two sentences working together, you have like your high level needs of like what the project needs to accomplish, and then you have your requirements that increasingly get more broken down as you kind of specify the design or work through the different stages of your product development. And so you basically want to make sure that every requirement that you write traces back to one of the needs, and that the needs are fully covered by the requirements at each stage that you go through. So that's that correlation of being able to see like, we're doing this because it traces back to this initial need. And then we can look at the needs and see, yeah, these are met by these different requirements. And that's how you get that certainty on the other side of the V, where when you get to verification and validation, that we're confident that this product will actually meet the needs because each of the requirements that we've listed trace back to one of those original needs that we've documented. And the earlier you do that, and writing your requirements in a way that's clear, concise, and correct will help ensure that later on you can go back and verify that each level actually meets those.
And then we have correct, complete. So the company standards and project requirement must be written in a way that accurately describes the minimal acceptable deliverable. So, are we getting what we're asking for in essence? Is this exactly what we need? And that's the main goal here is, we need to have exactly what works for us to deliver a project. At each stage, there must be no question that if the project meets the requirements, then it will meet the needs. So again, it's just reiterating, we're going to does what we're receiving, does it complete everything that we need? Have we met everyone's requirement, but are they, does this attribute to what our end goal is? Does this fulfill the need? Is it everything that we need?
Yeah, and then a perfect synonym for complete, as you can see at the bottom there, is complete. Yeah,
Exactly.
so that's good. We wanted to make sure that was clear for everybody. Completeness, not really another way to say it. So these are considered the 4 C's. There is also a 5th honorary C that gets thrown in a lot of the time, which is a really good one. And we see it in the sets of requirements, standards and rules that we've seen as well, which is consistent. So this can refer to the requirements being self-consistent. That's more along the lines of correctness, of making sure that the content is right, but actually consistency in using a common sentence structure and common terminology throughout the project, making sure that when you're referring to an entity, they always have the same name. And then also, if you're referring to a specific part of the system or a particular stakeholder or anything, they always have the same title. So you're not calling it, your company name in some places, then referring to yourself as the company elsewhere, because that can confuse folks that are reading through the document. So consistency in the way that you structure your documents and the terminology that you use is also important. So we'll go on a quick aside here about sort of rules in general. So how many rules should you actually try to enforce in your requirement writing? And a lot of that depends on the context of where you work. Is it something where you can iterate quickly if there's a misunderstanding of the requirement? Maybe then you wouldn't need to be as tight. But if you're working in a project that has multiple companies involved, multiple different teams involved, potentially hardware and software, and you might have firmware and different parts all working together, then defining the way that you write your requirements is even more important, because you want to make sure that everybody reading it has the same interpretation. So you could have one rule. And this is unfortunately what some organizations do, is they say, we hire good people, they know what they're doing, so we just tell them, write good requirements. So we all agree everybody should write good requirements. Certainly no advocates out there for writing bad requirements, whether you're doing, more of a waterfall approach or following agile methodologies. Nobody says write a bad requirement. So you could say we all agree on that. The next level up might be like our 4 C's plus 1. We can say 5 rules of, tell everybody, be clear, be consistent, be complete, and be concise. So if you follow those rules, then everything will work out fine. Then you have something like in the International Institute of Business Analysis, so IIBA, they would have 9 rules for when a business analyst is documenting requirements. There's 9 kind of best practices to follow. And a lot of organizations land around there with the rules that they encourage people to follow. The International Council on Systems Engineering has sort of the most robust rule set that's out there, where they've defined 41 rules in order to achieve these characteristics of a good requirement. So they get really specific here with, what types of words you should use and which ones you should avoid, and how things should be structured and how you should lay it all out. It's an excellent resource. It's a heavy read, but it actually does give you really good guidance into specifically how to write clear requirements that can't be misinterpreted or misconstrued as you move later on in the project. And then the largest that we've seen so far is one of the companies that we're working with. In my scale here, it isn't to scale, but the largest what we've seen is 500 rules approximately. So there's a team of technical writers that take the work in from the subject matter experts that define their company standards and things that they work on. They estimate there's about 500 rules that they try to enforce and get people to follow to make sure that everything is clear. So they obviously understand that the importance of clear documentation and writing your requirements in a clear way. But there is sort of the law of diminishing returns here. So, on the one side, you have the subjectivity of the rule. If you say, go write good requirements, super easy to follow. Everybody has their own interpretation of it, but highly subjective. So you don't want that subjectivity, because you're going to get mixed results. Everybody that's working on the project will have a different understanding of what they consider to be good requirements. And so it's too subjective, even though it's easy. The other end of the spectrum, you might find that there's too much effort for the context of what you actually get out of improving your requirements to that level, because the rules are hard to follow, or getting everybody to memorize them, actually verifying that all of your requirements follow all of these rules. It can be a lot. So wherever you fall on this scale, and this is where we come in as QB Scribe, we're going to show you a little bit, for those of you that aren't familiar with what we do, of how we fit into that process, is actually trying to pull those two apart from each other. So, however many rules you try to enforce, if you can actually decrease the subjectivity of the way that you write requirements, while also reducing the required effort that it takes to achieve that level of certainty and that level of clarity in your requirements, then that's a win. Because the only downside really to more rules is the required effort that it takes to enforce and apply them. And then the downside to just saying like, oh, go write good requirements is that it's highly subjective. And so if you can pull those two apart and find a way to further define your requirements process without actually increasing the workload, then that's a win-win, and it's going to give you benefits later on. I think of a good example of this. It kind of has a double meaning. You can look at it from the perspective of rules that you expect your team to follow, of like, hey, this is the way that we're going to write requirements. And you can also look at it from the perspective of your requirements themselves. But I have a 17-year-old stepdaughter who just got her driver's license, and we had to set out some rules for what it means, like when she has the car, when she's able to drive it, what time it needs to be home, all those sorts of things. And what we decided to do was the Honda Accord that she'll be driving in the family is named Boris. So we came up with the Boris contract. And the idea with the Boris contract is just this lays out the things that we're going to do, what we're going to provide when it comes to insurance and the vehicle and the maintenance, and then the things that she's going to provide in terms of the gas and the times that she's able to do the car. And we just, the times she's able to use the car. And we just documented everything out. So I have expectations about her use of the car, and then she has expectations around how she's going to use the car. And if we don't document them, it doesn't make the expectations go away. It just means that there's going to be conflict between our understanding of how this is supposed to work. So by laying out those rules up front, whether it's in the practices for requirement writing that you follow, or the contracts that you laid out of what you expect your contractors or your suppliers to deliver on, if you document everything clearly in a way that they understand, not necessarily every minute detail of how it's all going to work, but what the expected deliverable is, then it gives you a better chance of straightening that line as much as possible and reducing the additional rework. So Kyle's going to give us an example of how this looks within QV Scribe. Here's how QV Scribe aligns with those different kind of 4Cs plus 1 that we looked at before. There's different checks that we do across a couple of different types of analysis within QV Scribe. Kyle's going to show you a few examples of these here right now. For those of you that aren't familiar with it, QV Scribe is a requirements analysis tool, and it actually helps with the early detection of errors as you're writing requirements. So this quote from one of our customers with Honeywell Aerospace, the quality metrics based on a user-defined library of words, that's the configurability part of it, brings an early detection of errors that can improve quality up front. So Kyle will jump in and show what this looks like. We have versions of QV Scribe available for Microsoft Word and Excel. That's what we'll be showing you here today. This can interface with different tools and different systems that you would have in place that are out there. If you receive PDFs from a customer or you're working with a different management tool, if you can get it into an Excel sheet, you can analyze it very quickly. And then we also have direct integrations with select management tools, Polarian, DoorsNext, and JAMA. But I will turn things over to Kyle to give us a little tour of one especially poor requirement and how we can clean that up a little bit with QV Scribe.
Perfect. So here we go here. So what we did is we discussed kind of during our presentation, we wanted to see what standards should we look at. So this is a standard, we pulled this off of the just a public standard for pipeline preparations. And what we did is we said, okay, you know, it's in Word, as you can see here. So it's a Word document, wasn't too outside the box for anyone. And we thought, okay, what sort of standards, what dilemmas, what issues do we look at, you know, that we see problems with? So we toyed around, do we need 3, 4, 5, 6 different standards to illustrate kind of what we do and how we can benefit through our tool of QV Scribe. And ironically, it took us one standard to accomplish everything we wanted. And we looked at the first one and it just popped out. And as we put it into our system and use the analysis, the first thing that's always apparent, which we talked about already, is how many different requirements are in one requirement. So this particular one really had 3 plus an attribute. So we went, okay, let's take a look at this. Let's break this down. So what is stage, you know, step 1? So the first thing we looked at was, you know, we said, okay, we need to break it into individual. So that's what we did just down here. We took these 3 different requirements in one attribute, and we said, okay, let's make it. So we looked at what the contractor is responsible for, and we broke it down into the 3 different with one. Next, we looked at, okay, what are the problems that can occur? And our system has been kind enough to show exactly what, you know, what are the issues that can happen. And it also gives us hints on how this can help. So First thing it said is, look, similarity. So when we start to look at words that can really cause problems like similar diameter, suitable, working height, similar, these are words that have, as we talked about before, they're subjective. They can be interpreted, whether they're interpreted in a good way or a bad way. Mistakes could be made just based on that. So by looking at this and breaking it in, we've now taken a look. And then in the next stage, what we did is we said, how do we make these better? So we have 4 individual statements and we looked at each one. So in the first one we looked at, and this was a pretty clear, its was a word that we really, evaluate its condition. Why don't we say what it is instead of just using, a word that doesn't, it's a cross-referencing pronoun. Let's take the time. Let's write it correctly. So as you can see, we brought it down and we said, look, we're talking about the pipe condition. Let's, in the casing, instead of using its, let's use the correct verbiage. Second one, as you see here, was a bit more work for us. There was a lot of words that can be interpreted in a very, in a way that could be beneficial to the contractor. So we're really giving them the power now. If they felt it was a similar diameter, if they said this is suitable for their working height. So what we wanted to do is show by clearing these up and getting rid of any miscommunication, it can lead to a very, an end product that's much better. Because if you had a piece of piping that was larger, but you said it was similar, or you feel that this is suitable when it really is not, these are issues that can happen. So by reevaluating, cleaning up the process, and really being concise and clear, you're seeing that the requirement A can be tested, can be verified, and it can be fulfilled much easier without any guesswork, preventing phone calls, preventing work delays, preventing anything that can cause issues later on in the project. And then we looked here, we do have, so this is the beauty of our tool, is we can accommodate, and because we're working in newer fields now, we're getting, we're working in an environment where we are dealing with contractors, we're dealing with spec writing, we're dealing with, with the oil and gas, architecture, construction. So we have the ability through our default configuration to use real words that you will write in, as opposed to words that maybe systems engineering write in. So by allowing different words or standards, to be used, we do have the ability to accommodate your needs as a organization. So if you prefer to write with wills and mays, we can accommodate that. And as you can see here, what happens once we change it, it does allow these now to become much easier to read, and it accommodates your natural writing abilities and complements your workers.
Yeah, and in this case, we do have folks that are using QVScribe for like industry standards, but also company standards as well. And so according to ISO, the different words that you use in place of shall actually have meaning. So in this example, we're considering putting a configuration like this in the starting point with QVScribe as opposed to just our default. But what this allows is actually, if you're using may, can, and should in a controlled way. So should would be a recommendation, may would be a permission, and then a can would be something that could happen. Is by using may, you actually make it clear that this isn't requiring something. You're actually saying that this is something that they're allowed to do. So by rewording that one as the contractor may use gravel and or mats in the well area as a base to stabilize the rig, that's more clear than the passive voice in the one above, where it was just laid out as gravel and or mats may be used. So if I'm reading that as a contractor that's trying to bid on this project, I don't know if that's telling me that when I show up to the site, gravel and mats may be there, so I should be aware of that. Are you giving me a statement, or are you telling me something that I need to do, or are you telling me something that I'm able to do? So that structured language, and basically by adjusting the configuration in this way, QVScribe will ensure that every statement that you have has one and only one of those phrases. So the shall, may, should, can, would be included in each requirement statement. So that's how these ones are able to get a 5 out of 5 by saying, hey, this isn't a shall, this one's actually a may. But in a systems engineering context where you're actually defining the way that a system is supposed to behave, then you're only dealing with shalls at that point. So that's a way that could be used a little bit differently for like a standard or a procurement document versus the way that you would typically in a systems engineering context.
All right, so let's hand it back to James.
Alrighty,
Bring
and
it back up.
Yep, I'll share my screen again here. And so that's the end of the kind of core presentation that we have here today. I've got a couple of other quotes that you might find interesting and people to follow in the systems engineering world. But as we're getting close to the end here, I did want to remind everyone that if there are any questions, now is the time to enter them in. I do have one that I'll cover here right now from Mark. Good to see you again, Mark. Thanks for joining. He said, from a systems perspective, you should start with features. And how do we gauge their efficacy, clarity, etc., since they would drive the requirements? And that's when we're looking at something like the V model, that's a really good question, because you do have certain parts of the requirement of parts of the system that are defined going into it. Those could be customer needs that you're modifying something that they've started with, or you're taking components that they already have in place and using those. And so when you look at the V model, it's not necessarily that you start completely from scratch at the beginning of saying, like, we're going to make up everything and then try to build it from there. You can actually have lower level requirements that are introduced earlier on if you know that that's going to be a constraint of the system. So if the stakeholder, so maybe your customer, identifies that a particular component needs to be reused as a part of this, then it's going to enable some new feature, and you need to make sure that those two work together. You can actually define, and this is according to the INCOSE best practices for requirement writing, is you can define those lower level requirements as a part of the process early on. You just want to make sure that they're properly identified as such. So that's going to be a part of those lower level specifications. And so you do kind of travel up and down in those levels, those layers of the project as it moves along, because you're defining the higher level things as you also kind of flesh out the design, and then your design gets more and more constrained as you move through that process. So there was a bit of a comment and a bit of a question in there. If I didn't answer it, Mark, feel free to follow up on that. And yeah, if there's any other questions as we go along, certainly keep them coming. Appreciate that. So I just want to share this one too. So we looked at the quote from Honeywell, which of course is in aerospace, is following a systems engineering mindset. Shell is actually moving in that direction. They're taking more of a systems engineering approach to the way that they develop projects and write the requirements. And QB Scribe has been a part of their process for a number of years now. And this quote, they said that QB Scribe is helping Shell engineers write high quality requirements to ensure clarity across our projects and supply chain, which significantly reduces the number of questions and clarifications from our suppliers and enables more efficient execution of projects. So at each level and each stage that you go through, and again, I mentioned you'll be introducing requirements and bringing in contracts at different times through that process and what you're looking to accomplish. But by ensuring that the requirements are clear, whether you're writing high-level requirements of how this whole project needs to work or getting into the very specific behaviors of a way that a system is going to respond to different situations, ensuring that there's no misunderstanding of those requirements is incredibly important. And then taking it back a level here, now looking at this, again, of just thinking about systems thinking as a whole, kind of bringing the conversation back around to where we started. Requirements are a part of that, but it's not the whole part. So digital engineering as a whole, and following the kind of systems engineering best practices, there's a lot more that's involved with that, from model-based systems engineering to more advanced things like the digital thread that's happening right now, and how projects are all connected and how AI fits into that process. The systems thinking is much larger, and requirements engineering is a part of that larger kind of systems thinking methodology. But this is a great person to follow if you're interested in learning more about systems engineering as a whole. He's involved in the INCOSE community. He also publishes really great little videos that just help people understand the different elements of systems engineering, from requirements to modeling to different stakeholders and managing expectations and things like that. And I really like this post that he shared recently on this. He said, "I did have the good fortune of being on a web development project years ago, fairly small, where the project lead worked needs and requirements hard up front. The customer was a little surprised at so much interaction, but was grateful when we finished on time and delivered a product that really met the needs. Again, we did not have the time or money to redo anything on that one. So this could be the equivalent of applying a mindset of how you would plan for a wedding to a night out with everybody. You could think of it as maybe being a little bit overkill, but you could definitely do that process very quickly if you were planning a smaller project by implementing some of those better processes. But also, if you try to apply the old way and the way that projects were managed when they weren't as complex as they are today, you'll certainly introduce new problems into that process as well. So definitely follow Raymond, find him on LinkedIn. He's got great posts and great videos that you can check out there as well. And just before we wrap up here, we've just got another few minutes, so we'll open it up for any questions. I do see a few being listed here. Somebody asked if we would be sharing the recording of this. Yes, as far as we can tell, everything has been recorded. Everything has been recorded here. As far as I can tell so far. And I'm just going to check the questions here. And give me a second to read through them. All right, there was a great comment there, and I'm going to read it. Hopefully I get the point across I was listed. So this one came through. It says, train not fitting into the tunnel reflects a failure to adequately define systems engineering management plan and the concept of operations per your V model diagram. So that would be at the top of the V. But we're not adequately identifying what I call the real business requirements, the business deliverable. So what provides value when delivered and includes accurately identifying and addressing the relevant needs. These are content, not merely clarity issues. Did the project fulfill the need is sufficient only when the need is actually accurately identified, which the correct rule is not sufficient to assure that Babak, that's the BA book of knowledge, are essentially oblivious to. So thank you for sharing that comment as well. It is certainly the correctness of the requirements, like when we talk about the scope of QV Scribe, and really any tool, if you're using a sort of AI assistant or any sort of assistant for requirement writing, we are helping with the clarity of the requirements, but certainly that idea of making sure that you have the requirements correct is not something that can be fully automated. And even when we look at things like ChatGPT that are out there, which don't put any sensitive information into that, but it's good for kind of the ideation side of things and being able to think through, did I cover all the requirements? Is there anything that that I've missed? Things like that can help you ideate. But what's going to happen in actually defining the requirements and using tools to help with that is it's making sure that what you've defined is going to clearly be understood by everyone that's involved in the process. And that's where business analysis is key, to make sure that you've identified the right stakeholders, that you've gotten the right opinions, and that whole high level set of requirements actually does make sense in that context. So thank you for sharing the thoughts there. And there was one other question that we can cover here, which was, how could you, sure I get this right, and you can follow up, how could you improve a current project with this thinking of systems mindset? Do you see an application of this mindset for projects that are currently in development? And we'll close on that question. I'd say, and certainly if anybody else in the chat has thoughts on this as well, but that question of how could you apply this to a project that's like already underway? So maybe you're in the middle of something and you say, hey, this would be great if we actually did have all of the needs clearly documented up front, but maybe we've received customer requirements that were not very clearly defined, or we're in the middle of something and we can't really go back and redo everything from here. I guess that's where those levels come in, of if you're already at a particular stage and you haven't really done the due diligence in the early stages to make sure that those requirements all trace back to those original needs, you can go back and try to document some of those things. Like I said earlier, the requirements always exist. It's just whether or not you've documented them and thought them through. And so taking that process of just going back and thinking through, if all that we had was the requirements, were the requirements that are written in front of us, and that was all that was delivered upon, would this actually meet the goals or are there gaps in it? That can be a helpful way of just making sure that you don't have missing requirements and that all of those needs that you've uncovered earlier on, maybe that aren't documented, gives you the best chance of covering some of those as well.
And that's true, Gene. It's just like you said, you may not have written them down, but you have documented them. It just could be from experience that the process, and the process is memorized. But we're just encouraging you to write them down to verify them versus I think. Now you have I will or I shall. So it's really putting it together in a way where just sometimes we've done it so many times we do not feel the need to write them down. But once you start to write them down, then it'll actually pull apart more things and make sure that they're traceable, they're verifiable, and that's the whole idea behind it.
Yeah, and those different levels too, it's all about alignment. It's making sure that, and that's why, even if you're using modeling and different things, that the written requirements are so important, is that anybody can read a document and understand, if they've done well, understand what it is that at least the project is looking to fulfill. So that's something that your modeling and things like that can be an important part of understanding and fleshing things out. But the written word is the way that everybody's going to read and understand that, yes, this is what we want this project to fulfill. So appreciate everybody in taking the time here to join us today. And those of you watching the recording, thank you, Kyle, for the great presentation. And we have the next one coming up in April. We're going to be diving into EARS. We'll have a panel discussion here on the easy approach to requirement syntax, which is one of those ways to actually formulate your requirements. So we'll look forward. You can't register for that one yet, but keep an eye on the website, and you'll, if you're on our mailing list, you'll get the email in the next couple of weeks here when that one's coming up in early April. So thanks again, everybody. Appreciate you taking the time, and feel free to reach out if any of you would like to have a follow-up discussion on this. We'd be happy to connect with you. All right, take care.